So at the end of the last set of videos, we talked about 3D stress transformations. So what this is stating is if we have one state of stress, let's call it sigma xyz, right? And we want, so that's the state of stress in the xyz coordinate system. And we want to transform it to another coordinate system, which we're going to label as the x prime, y prime, z prime coordinate system. In order to do that, we need to know the relative orientation of the x prime, y prime, z prime coordinate system relative to the x, y, z coordinate system. So in order to do that, we need to know the angles between um, the original coordinate system, or the x, y, z coordinate system, and the new coordinate system. For example, for the x-axis, we have um, theta x is the angle between the original x-axis and the x prime axis. We have theta y, which is the angle between the y-axis and the x prime axis. And we have theta z, which is the angle between the original z-axis and the x prime axis here. Okay, so using these angles and the directional cosine and using these angles, and we put them inside a cosine function, we can determine the projected areas along the x, y, and z directions for this stress element that's been cut at a plane that is normal to the x prime axis. So so if we do that and we then sum all of our forces along the x prime direction, we can then solve for sigma x prime. And then if we follow a very similar process, so if we sum all the forces along the y prime direction and the z prime direction, and so those equal to 0, we can come up with a set of algebraic equations for all the different stress components. So if we do that, this is what we end up getting. So we'll end up getting these set of 6 algebraic equations here, which we can rewrite in terms of the matrix form here. Right. And using this matrix form, we can calculate all the stresses using one set of calculations. But you can use the algebraic system as well. That's totally fine. But the transformation matrix equation, I think, is a little bit more straightforward and concise. So